I'm Dodd Brown. I'm the general manager of Telesat US, and I'd like to talk today about our theory that we are at the beginning of the age of optical commercial space networking at scale. My theory on this is based largely on my own company, frankly, and the commitment we're making to optical ISLs, but also the things that are going on in government where new network theories are being based on the wide deployment of optical intersatellite links. In commercial, we recognize that optical intersatellite links are essential to future high performance, low latency mesh networks, very similar to terrestrial fiber networks on the ground. In government, optical ISLs are essential to next generation resilient space relay and proliferated LEO networks. In the commercial world, the evidence of this is with Telesat, the company of which we're a part. Optical ISLs have been native to the Telesat LEO design from the very beginning. On every Telesat spacecraft, as you'll see, we have 4 10 gigabit per second OISL terminals that enable us in every direction to support mesh networking. In the government, in the US government particularly, you have what's going on with DARPA Blackjack, with optical ISLs as a part of a demonstration network, Space Development Agency, Space Transport Layer, which is in fact based on optical ISLs. The developments with NASA Scan in terms of next generation commercial services program, and very much with the efforts of SMC Casino program and the Chief Partnership Office, all driving towards a vision of optical intersatellite links as a foundation for future networks. We argue that in 2021 to 2023, this is a pivotal time. This Optical Communications Workshop actually notes a real milestone in the use of optical systems in networks of various types and kinds, both commercial and government. And we're the greatest commercial example. We are about to deploy a network that is based on the procurement of approximately 1,200 optical communications terminals for OISL networking. 1,200. I would argue that by any definition, that is OISL networking at scale. As I said a moment ago, OISLs have been native to our design from the very beginning. And what you'll see here is they're a part of a system of very advanced components that allow us to create an extraordinarily high-performing global high-throughput network. First, we have secured over approximately 4 gigahertz of global spectrum. We have very advanced direct radiating antennas that allow us to dynamically manage the use of the spectrum and power in our network globally on a nanosecond by nanosecond basis. In order to drive that on the spacecraft, we have very sophisticated onboard processors aboard each spacecraft. And in order to create a network of those components, we came to the conclusion that we had to have optical intersatellite links in order to be able to communicate with the kind of throughput, and as I said before, it's 10 gigabit per second per terminal system. So those are incredibly powerful components when you talk about mesh networking. Of course, let's not forget that we'll have landing stations distributed throughout the globe. And also extremely important, we have a thing called the Constellation Network Operating System, or CNOS. That is a system to allow us to dynamically manage both space and ground assets so that you're constantly and autonomously responding to the demands on the system based on requirements from users scattered throughout the globe. For the government, this means something pretty extraordinary. Telesat LEO becomes a global self-healing mesh network that enables government users to do something extraordinary because of optical ISLs. You can come out of a region up to our spacecraft, come back down anywhere on the globe without touching any of the other ground stations within their originating region. That is what the government is calling a unilateral requirement. It's very powerful. If, of course, you're in a region that has a communications environment that is highly contested and congested, you can come out of the environment to space, optical ISL, spacecraft to spacecraft, and then come back down in the United States or wherever else you want to go. A very, very powerful thing, which is really enabled by optical ISLs. That brings another element, which is space relay. So this mesh network becomes a resource for spacecraft on orbit as well that may connect via RF or optical. And in many cases, we're looking at optical as the system, and we'll talk about that in a second. Last thing I'll tell you is, as you can see on the chart, this enables very low latency, very high throughput satellite communications in anywhere on the globe. It's very, very powerful, where when you're getting these round trip times like you see, well less than 100 milliseconds, as you can see below. Just to illustrate this is notional. This is very much a cartoon, but our design is based on, as I said before, 4 optical intersatellite links on each spacecraft. You could see them pointed out there, and on each of the elements of the nadir facing deck of the spacecraft. And what do you do with those? Well, we use those 4 terminals, as I said before, to create a mesh. And the optical ISLs provide both in-plane and out-of-plane communications links driven by the onboard processor at up to 10 gigabits per second. This enables us really to operate our network, which, by the way, will be at low Earth orbit, 1,000 kilometers up, 1,350 kilometers up, polar and inclined networks that will function as a global mesh. As I said a moment ago, it also enables us to provide networking in space, and let's talk about that for a second. One of the really big milestones is Blackjack, and it's core, I believe, to the rethinking of the way that the United States and our allies look at military space. Blackjack is looking at new space architectures that are based on some of the developments in the commercial LEO world, both in terms of the manufacturing principles, the supply chain, how you deploy spacecraft, and also what happens with the economies derived from mesh networking in space. I'd also like to point out something that I say on the slide: autonomous networks. That's our CNOS, where you have artificial intelligence driving the reconfiguration of your network. The most important thing, though, on this chart, which is a very early 2018 chart of Blackjack laying out its objectives, one of the most important things is, of course, optical intersatellite links. And that has become a key part of Blackjack. We're very proud to be a part of the Blackjack program. We've completed phase 1. We were selected and have signed the contract for phase 2 of Blackjack. And here you see a diagram of what a Telesat, LEO, and Polar network would look like communicating with Blackjack LEO. Those spacecraft, by the way, would in some cases be derived from our spacecraft bus, highly modified to include military payloads, or we will connect via OISL to other performers' spacecraft, but creating a network in space that's very resilient, self-healing, as I said, and allows extraordinary low latency communications anywhere in the globe. Two things just very quickly I will tell you is that we're providing two 2 kilowatt spacecraft buses for the larger Blackjack constellation, but immediately we're flying 2 Croupier risk reduction spacecraft, we call them Croupier, that will enable us actually to try out and demonstrate optical intersatellite communications based on military payloads on commercial spacecraft. We're doing this in the context of an immense amount of modeling simulation, talking about how do commercial networks and military networks coexist in space. Here's the Croupier program, very important to our optical communications world in 2021. We'll be flying those spacecraft. DARPA will be putting them on orbit in third quarter 2021. They'll have 2 OISLs each from different optical intersatellite link providers. So interoperability being the key, a Ka payload, a processor, and as I said before, a military payload. One of the key things is demonstrating communication between our 2 spacecraft and other DARPA spacecraft that will be also launched, 2 of them in an early risk reduction mode in 2021. Very, very powerful milestone in 2021 for the optical communications community. Also, we should note that in 2022, you'll start to see launches for Space Development Agency Space Transport Layer. They call it Tranche 0, as many of you know. Actually, dual role, our Croupier demonstrator will be used by SDA in league with DARPA to demonstrate some of the principles in 2021 that they want to explore. But also, we are a member, Telesat is a member of the Lockheed Martin Corporation Space Transport Layer Tranche 0 team. We're really proud of that, actually. Lockheed Martin is going to be flying spacecraft in 2022 as part of Tranche 0. Our job on that team is to work with Lockheed in the development of OISL deployment and interoperability on those spacecraft as part of the foundational test and demonstration Tranche 0 layer. Between DARPA and SDA, 2021, 2022 is going to be very important for optical intersatellite link communication in the government marketplace. Say very, very quickly, one of the things that we are very proud to have participated in is SDA is developing open standards for optical intersatellite links. Very, very important for interoperability. And they're focusing the community on, and the performers on Tranche 0, on what is the path to widespread communication between different optical intersatellite link configured networks, so that you could really have a global government and commercial mesh that is exceedingly resilient, powerful, very hard to disrupt, as long as you could talk to each other. SDA, as part of its performance under Space Transport Layer Tranche 0, is very focused on that. At the same time, I'd like to point out that Space and Missile Systems Center, part of United States Space Force, is modeling the communications between commercial and government networks. We're supporting General Dynamics Mission Systems and others in those efforts to figure out how do you optimize? How do you get the most military utility out of these systems, which are by themselves totally game changing in terms of their performance, but may in military applications have some very extraordinary characteristics. Working hard, Space Force is focused on this, and the SMC Casino program, as well as the Chief Partnership Office of the Space Force out of SMC in LA, is also leading this initiative. So I think I can very confidently say that my thesis that we're on the threshold of a new world in optical communications in space. We've talked about Telesat LEO's commercial deployment at scale. We've talked about the blackjack demonstrations, SDA Tranche 0 and 22, as well as the modeling simulation that's going on now, and the efforts that NASA is making under the Commercial Communication Systems Program to define the role of optical and RF networking in space, space relay, in support of NASA missions. It's a new age. The next 2 years will be extraordinary. And from there, we will be building networks in space. We're at the threshold of the age of optical space networks. Thank you very much. Appreciate your attention. And let's get back to the panel.